Today we're going to look at isolating the variable, the most important skill you could ever have in algebra. Basically, we're going to be isolating x. We're going to make x feel all by itself. And the goal is this. We want to get the variable on one side of the equation, and we want to get the number on the other side of the equation. Sorry about the drawing. So we look at this equation right here. This means in words, a number plus 7 is equal to 20. And intuitively, you could figure this out. You could ask yourself, well, what number added to 7 equals 20? And you know that it's 13. The thing is, we have to prove it. And so to do this, we must reverse the order of the operations acting on the variable. What does that mean? We're going to use Santa as a little helper. He says ho, ho, ho. We're going to use the HO. The H stands for what is happening to x, and the O is the reverse, or the opposite of what's happening to x. So if you look over here on this expression, we have a number plus 7 is equal to 20. Well, what's happening to x? X is being added by 7. And the opposite of adding 7 is subtracting 7. So the next line is going to look like x plus 7 minus 7, because we're going to do the opposite. The thing is, we have to do it to both sides. Because it's a balanced equation, we have to do it to both sides. So it's going to look like this. X plus 7 minus 7 is equal to 20 minus 7. So because I've done it to the left, I have to also do it to the right. These two are going to cancel out. If you add 7 and take away 7, it's 0, right? It doesn't make a difference. And then you can do the subtraction right here. 20 minus 7 is equal to 13. Let's look at another example. A number plus 4 is equal to 10. Intuitively, we know it's 6, but let's prove it. What's happening to x? Well, it's being added by 4. The opposite is subtracting by 4. So the next line is going to have x plus 4 minus 4, because I want to get rid of these numbers on the left-hand side. It's also going to have a minus 4 on the right-hand side. These two will cancel out. If you add 4 and take away 4, that's 0. It makes no difference. And then we can do the subtraction, and we end up with 6. In this case, it's a little bit different. There's no addition or subtraction. We have multiplication. And I know this is multiplication because I do not see an operation. I just see a number and the variables sort of slammed together. Whenever you have that, it means multiply. We look over on the right-hand side. Let's describe it. What's happening to x? It's being multiplied by 2. The opposite of multiplied by 2 is divided by 2. So I have to divide this expression by 2 to get rid of the multiplied by 2. But I have to do it to both sides because it's a balanced equation. So the canceling out looks a little bit different here. I'm going to multiply x by 2, but then I'm going to divide by 2. That means that those two operations, they cancel each other. So I will be left with x. But because it's a balanced equation, I had to introduce that divide by 2. I still have to divide the right-hand side by 2, and I get 5. Look at that, another one. In this case, describe what's happening to x. It's being multiplied by 5. So the opposite of multiplying by 5 is dividing by 5. So I have to divide the left-hand side by 5 to get rid of the multiply by 5. But I have to do to the 50 as well. If I'm going to put a divide by 5 on one side, I have to introduce it on the other side. It's a balanced equation. In this case, multiply by 5, divide by 5. They cancel out. Over here, 50 divided by 5 is equal to 10, and x is equal to 10. And this one's a little bit different. What's happening to x over here? So we see x expressed as a fraction. It's also an operation. X is being divided by 2. And what's the opposite of dividing by 2? Multiplying by 2. So to get rid of this divided by 2, I have to multiply the right-hand side by 2. It's going to look something like this. But if I multiply the left-hand side by 2, I have to also multiply the right-hand side by 2. So here's the next line. If I multiply x by 2 and I divide x by 2, they cancel out. But on the right-hand side, here's that multiplied by 2 that I introduced because it's the opposite. It will add up. The product will be 20. But what happens when there's more than one operation? For example, if we have multiplication and addition, what's really tricky about this is you actually do the reverse of the order of operations. Normally you do, for example, addition comes after multiplication, but because we're isolating the variable, we're doing it backwards. We do addition before multiplication. Normally we look at the brackets first, or the parentheses first, and we solve what's ever inside of it. But because we're doing this backwards, we solve what's outside first. So everything goes backwards. Here's an example. In this case, we have 2 times x, and we have plus 3. Normally, we would do order of operations states we have to do multiplication before we do addition. But because we're doing this backwards, we do the addition first. So what's happening to x? Well, it's being added by 3. And what's the opposite of adding by 3? We're going to subtract 3. So we subtract both sides by 3. This will cancel out, and this will become 6. The next line will say 2x is equal to 6. In this case now, we have to divide by 2, or divide both sides by 2. Here, normally we always look at the order of operation and say, well, what's first, multiplication or addition? It should be multiplication, but because we're doing this backwards, we do the addition first. So if what's happening to x? It's being added by 4, and so the opposite is to subtract by 4. So we're going to subtract both sides of the equation by 4 to cancel out that positive 4. These will cancel out, and we're left with 5x is equal to 16. Here, same thing. We have a division, which should come before addition, but because we're doing this backwards, we do the reverse. We're going to get rid of this plus 5. So how do we get rid of plus 5? We have to subtract 5. And there we go. So we've got x over 5 plus 5 minus 5, but we do it to both sides because it's a balanced equation. These plus 5 minus 5, they'll cancel out, and we're going to have x over 5 is equal to 25. It'll look like this. X over 5 equals 25. And then we can do take care of the divided by 5. Look at the brackets. In this case, we would normally solve whatever's within the brackets. That's what order of operations tells us. But we're doing the reverse, so we do whatever is outside of the brackets first, which means we're going to take care of this multiplied by 3. What is the opposite of multiplying by 3? We have to divide by 3. So we're going to divide the whole left side and the whole right side by 3. And watch how I cancel. This times 3 disappears because I'm going to divide by 3. It's the same thing. If I multiply this expression by 3 and divide it by 3, that cancels out. The right-hand side, though, will become 4. And I'll have x plus 1 is equal to 4. So you'll see there's the next line. Now I can take care of this addition. I'm adding by 1, so I have to subtract by 1. I subtract both sides, and I get 3. This one's a little longer. Let's go one step at a time. Normally we take care of whatever's inside, and then we go, but we're going to do the backwards. Now we have a multiplication of 4, and outside of the brackets we have this minus 2. This should be the last thing, but because it's backwards, it's the first thing we're going to take care of. So how do we get rid of a minus 2? We add 2. So we do minus 2 plus 2. Those cancel out. The right-hand side is going to have 12. Next step. We have multiplication outside and some addition on the inside. It's backwards, so we do the outside first. 4 times x plus 1 is now at 4 divided by. We have to add a divided by 4 because it's the opposite. These two will cancel out, and we're going to be left with x plus 1 equals to 3. And that we can solve very easily. How do I get rid of a plus 1? I subtract 1. And I subtract 1 on both sides. Last one. 2x plus 3, we have to get rid of, we have multiplication and addition. We do the opposite of the order of operations. We're going to get rid of the addition first. We're going to subtract by 3. These will cancel out, and we're left with 10 on the right-hand side and 2x on the left. So we've done, you can even check mark it if you want. Say, yes, we've done this. Next, we've got, x is being multiplied by 2 right here. And what's the opposite of multiplying by 2? Divided by 2. So we're going to do that next. These two will cancel out, and x will be equal to 5. Try these ones by yourself, and I'll just pause for a couple of seconds, and then I'll put the solutions up. This is solution A. I'll show it step by step. Solution B. and solution, oh, sorry, still B, and solution C.